To undo a mathematical operation, you must do the opposite. So here we have 8 equals d over 10. You can do anything you want except divide by 0 to one side of an equation as long as you do the same to the other. So we undo d being divided by t by multiplying both sides by t. So here our operation is divided, so our inverse or our opposite would be to multiply. So here is where we're multiplying both sides by 10, which as you can see here is undoing or crossing out the 10s, leaving us with 80 equals d. Are we done now solving for our variable? Think about our 4 rules. Think about what our goal is when we want to solve. You should answer that no, we are not done. You can always switch the left and the right sides of an equation because in order to be done, we need our variable to be on the left. So here 80 equals d, we're just going to switch to have d equals 80. And now we are solved for our equation for d because d is all by itself. It's alone on the left side. Little check mark to show that we're done. When solving equations, the goal is to isolate the variable on one side of the equation in order to determine its value, the value that makes the equation true. So here the goal is to get x by itself on one side of the equal sign, and we generally want it on the left. So let's look at x plus 7 equals 32. Again, we want to think what would make the x be by itself. For each equation, let's write the inverse operation needed to solve for the variable. So thinking of our inverse, if we go back, what is happening to the x, we can see that it's being added by 7. Right? That's adding by 7. So its inverse, we would need to subtract 7 in order to get x by itself. Here, let's think about our inverse operation. We have y plus 7 equals 14. So here we are adding 7. So the inverse operation would be to subtract 7. For b, we have a minus 21 equals 10. So we're currently subtracting 21. So the opposite would be to add 21. Here we have 5 times s equals 25. So we're multiplying by 5. So the opposite or inverse would be to divide by 5. And finally, we have x divided by 12 equals 5. So we're dividing by 12. So the inverse of division would be to multiply by 12. In each case, you analyze or identify what operation is currently happening to the variable and what's its inverse, what's its opposite. Now think about this. To solve c minus 3 equals 12, which method is better? So let's look at Kendra wants to add 3 to each side of the equation. Ted wants to subtract 12 from each equation and then add 15. Both are arriving at an answer of c equals 15. Discuss now which method you think is better and why. When I look at both of their methods, they do arrive at the answer, but Kendra only had to use one operation instead of 2 like Ted did. Kendra analyzed that it was originally subtracting 3, the inverse was adding 3, and that kept her variable on the left side and by itself in one step. So the better method in my opinion would be Kendra's. It follows the rules. Ted's was a little longer, but just required 2 steps. So both are correct, but Kendra's would be faster.